Welcome to the fifth ICCG webinar of its water series, today dedicated to changing water resources in Europe under climate change. And this webinar aims at giving an overview on observed and projected changes in water availability in Europe based on several indicators that are maintained by the European Environmental Agency and presented in its regular assessment reports. And the speaker of today is Dr. Hans-Martin Füssel, who is project manager at the European Environmental Agency in charge of climate change impacts, vulnerability and adaptation. And Dr. Füssel holds a master's degree in computer science from the University of Frankfurt and in applied system science from the University of Osnabrück. And he then obtained a PhD in physics from the University of Potsdam. And Dr. Füssel served as author of the IPCC Fourth Assessment Report and also consulted many international organizations such as the World Bank, the European Commission, UNDP, UNFCCC, WHO, IPCC, and many national governments on climate change. He joined the European Environmental Agency in 2010. And in 2012, he coordinated the report on climate change impacts and vulnerability in Europe. And he's currently coordinating the follow-up report, which is due to be published in 2016. Some of our researchers from FIM and CMCC have contributed to this, to both reports, so to the 2012 and to the follow-up. And in the context of the European Topic Center Consortium, which is led by the CMCC, the Center for Mediterranean Climate Change. And so today, Dr. Füssel will present the European Environmental Report, the State and Outlook 2015, and focusing specifically on water availability in Europe, and so water resources and also water quality. So I pass you the floor, so please go on with your presentation. Thank you.
Thank you very much for the kind introduction, and yeah, good afternoon to everybody listening here. Let me just briefly present for those of you who may not be aware who the European Environment Agency is, the institution and the mission. So the EEA is part of the EU family. We are the EU body that is dedicated to providing sound, timely, independent information on the environment. So we are an information source primarily for those who are involved in the development of policies, adoption of policies, implementation, evaluation, but we also have a, let's say, a wider audience, including the general public. We are based in Copenhagen, and we work with a network of institutions in all the member countries, the so-called EINet, which comprises more than 300 institutions, and one of the institutions that was just mentioned is our European Topic Centers, who help us to work on specific topics. And so there is actually a topic center on water and a topic center on climate change, impacts and adaptation. And as mentioned before, CMCC is actually leading the latter topic center. Now our main clients are obviously the EU institutions, the Commission, the Parliament, the Council, but we also have very close contacts with the EA member countries. These are the 28 EU member states and 5 additional countries. So our Europe reaches from Iceland to Turkey actually. And we meet with them on a regular basis because a lot of, in particular, if we're now looking at climate change impacts and adaptation, most of the work is done at the national and subnational level, even though the EU is definitely supporting that. Yeah, it was already mentioned, the European Environment State and Outlook Report, also known as SVR Report. This is actually the flagship product of EA. It is published every 5 years, and we are actually required to do so. We are mandated to do so from our the regulation, the founding regulation of the EA, and the latest report was published a few months ago, and it has actually already been presented in 20 countries, or more than 20 countries, but as far as I know, not yet in Italy. So watch out. There are usually a couple of EA colleagues traveling and presenting the report to the parliament or to the government or environmental agencies in the member countries. Now, when I say the SVR report, actually it has now become a series of reports. There are 4 main parts: the so-called synthesis report, which is translated in all languages of member countries, and then there are 3 topical reports, one's on global megatrends, looking at those trends who affect Europe, and one of them is climate change, so there is a section on global climate change. Then a second part, or another part, looks at European topical issues, and here we look again at climate change from European perspective. And finally, there's a part where member states are compared, but climate change impacts are not specifically addressed here. Obviously, climate change mitigation issues, greenhouse gas issues are addressed because they can be easily compared across member states. Now, the information that I present has informed the SVR, and some of it is represented there. However, I'm drawing mostly on different reports here, which I will just present in a moment. And there are actually 2 groups in the EA working on issues related to climate change and water resources. One group has more the water focus, and they are leading activities on a number of freshwater related issues. And maybe it's good to explain briefly how EA actually works and shares its information. So of course we publish reports and other kinds of publications, and just to say that all the reports but also all the other information such as indicators and data sets are available, publicly available on our website. Another important outreach channel are web portals. And here you see the so-called WISE portal as one example. Of course, we give presentations such as right now, and we have a lot of personal contacts in the EU institutions in the member countries, and we also work with the media. This is just an overview of some reports, let's say with a freshwater focus, that were published in the last couple of years, and I will briefly mention or use information from one of them later. I also want to present briefly the WISE portal. It is meant as a gateway to information on water-related issues across Europe. And the data presented there, or that is accessible through the WISE portal, is collected mostly by EU institutions to serve a wide range of stakeholders. I should also say that the information here is mostly based on, let's say, mandatory data flows, such as where there is an EU directive, so the data is reported by countries. Whereas in relation to the climate change and climate impacts work that I will present in a moment, we rely more strongly on academic work, international institutions, and so on. So the WISE portal could be interesting for some of you to look for information there. And as I said, all the information is publicly available. I myself work in the second group, looking at climate change and water-related issues. So our focus is, let's say, the climate change perspective, which is a cross-cutting issue in itself. And for instance, when we look at climate change and water-related issues, we're not only looking at what it means for the water sector, for water managers, but also we look at agriculture, we look at nature protection, we look at energy production and the various systems and sectors that are affected by changes in climate change. Of course, that also means when we are talking about adaptation to climate change, it's about mainstreaming the consideration of climate change in the activities of many, let's say, different sectors. As other groups, we also, of course, publish reports, and personally I have coordinated a report, the most comprehensive report here on this topic on climate change impacts and vulnerability in Europe in 2012, and currently I'm coordinating the follow-up report, which is to be published next year. Our group also maintains a web platform, and once again this is a collaboration with the European Commission here. And this web platform, it's called Climate Adapt. It is supporting governmental decision makers at various levels, European level, national level, but increasingly also at a subnational level, to develop climate change adaptation strategies, policies and action plans. The WISE portal I presented earlier was launched in 2007, related to Water Framework Directive, whereas the Climate Adapt was launched in 2012 only, together with the adoption of the EU adaptation strategy. One tool that was already mentioned briefly in the introduction that we use for, let's say, synthesizing information are indicators, and we're currently managing around 40, some 40 indicators on climate change and its impacts in Europe. This is just an overview on the status right now. Most of them will be revised in 2016, and actually there are particular changes related to some of the water-related indicators, because if you just have a look here, basically what you see is the various parts of the 2012 climate impacts report, and in red highlighted those indicators that I will present in this presentation. You can already see that they are, let's say, distributed over quite a few different systems. And in the new report we make an attempt to bring information a bit better together, so that, for instance, drought-related issues are not addressed in 4 different parts of the report. And an indicator is meant to synthesize information on a specific topic. Many of the indicators that the EA managing have, let's say, more statistical properties, so that it's about reporting information on a country-by-country basis. However, this is not the case for most of the climate change and impacts indicators, because it doesn't necessarily make sense to, let's say, average sea level rise in Italy or in Spain across the whole country. The effects will be very different if you're looking, let's say, at the Atlantic coast or at the Mediterranean coast. So the information we present is usually at a higher spatial resolution. So looking specifically at those indicators dealing with climate change and its impacts, one could distinguish 4 different policy purposes. The first one would be tracing global climate change, and the key indicator here is global mean temperature. It doesn't necessarily inform directly any European adaptation policies, but is the indicator that is mentioned specifically in the UNFCCC. It was also mentioned just yesterday in the G7 statement on climate change, so it's kind of the global indicator, and there are a few other ones which are also relevant here. This presentation focuses on indicators that one could describe as tracing regional climate hazards, so they do inform climate risk management, and one of them mentioned here is regional sea level rise or extreme precipitation. Other indicators assess the sensitivity of ecosystems and society, and still others, let's say, start at looking at the effectiveness of risk management, but we are only in very, very early stages here. It is not easy to measure the effectiveness of risk management, in particular if you're looking at rare extreme events where the normal statistics just don't work. And so depending on the policy purposes, of course, that also has implications on some of the requirements for indicators, such as the length of the timescale, the spatial coverage and resolution, and so on. Before I go into specific indicators, it may be helpful to look at some of the definitions. It's also just to show some work of the water-related group, which does a lot of groundwork, of course also for the work on climate change impacts, and we work very closely together on most of these reports. So from the water perspective, for instance, it makes sense to look at different time horizons, short-term, medium-term, long-term, and also the different causes of, let's say, water shortages in the widest sense. And so if we look at short-term issues, we deal with dry spells and water shortages. At the medium time scale, with drought and water scarcity, and it's here where climate change slowly becomes relevant. And of course, on an even longer time scale, we could also look at issues such as aridity and desertification, but that is not explicitly addressed in any of the EA reports so far. Now, what I would like to do now is give an overview on a number of indicators, and which means you will see a lot of maps on Europe. I mean, maps, in particular for those indicators, are a really important communication tool, and you will also see that, let's say, the message in many of the maps is similar, even though the specificities change, and also in some cases the color schemes change. But I think we can give a pretty clear message here. So if we start, let's say, very simply at the beginning of the causal chain, looking at precipitation, this is a map of past trends, and without going into details, you can see that in general there's a north-south gradient. In the north, precipitation tends to have increased. This shows the trend since 1960 over the last 50 years, and in the south, in general, it has decreased. Of course, the details are more complex. This is just the annual information. We also have additional information for the seasons, which is actually very important if we talk about precipitation. And we can also see, if you look at details of where the dots are and so on, that not all the changes are yet statistically significant. Sometimes the coverage, data coverage is not enough, or the time series is not long enough to say whether an observed change is statistically significant. And of course, that information also needs to be communicated. If we now look at projections, the big picture stays the same. We see once again a north-south gradient. Blue means increasing precipitation, and yellow, orange, red means decreasing precipitation. On the left, you see the annual changes, where from that perspective, let's say, obviously some Mediterranean regions are affected by decreasing water availability, but it doesn't look very dramatic. However, if you look at the right map, focusing on the 3 summer months, then you can see that for many of those regions, a very strong decline in precipitation is projected. And of course, if you look at the indicators on the website, you find more information. What are the underlying scenarios? What's the time horizon? What models have been used? I mean, this is a multi-model ensemble, I can say, from the EuroCordex project, but for further information you would have to go to the website or to the report. But this information is actually updated compared to the report. Yeah, maybe that's also relevant that these comprehensive climate change impact reports are published every 4 years, but we do increasingly update the indicators more regularly. For instance, about half of the indicators covered in this report were updated last year, mostly taking into account new information from the IPCC Fifth Assessment Report, but also from other important projects and activities. Okay, if we now look at extreme precipitation, this is an indicator that will change in the 2016 report, separating let's say the heavy precipitation and those parts that are more relevant for droughts, the low precipitation. So this is just one part of that indicator, focusing on projections that are relevant for droughts. And here the specific indicator is the length of dry spells, that's the period without rain. And here you can see again that the length of dry spells is projected to increase significantly in southern Europe, in parts of Central Europe, in particular in summer. Well, that seasonal information is not shown in this map, so there you would have to look at the report or at the web-based indicators. And the picture is different in Southern Europe than in Northern Europe. Now, precipitation is obviously a crucial factor for water availability, but it's not the only one. Issues such as evapotranspiration from soil, from plants, ice dynamics, all are additional factors that then affect water availability and river flow. And those are also temperature sensitive. So increasing temperature in general means a higher evapotranspiration, which means that even with the same amount of precipitation, you have less water available in rivers or groundwater. And if you look at ice melting in those regions affected by glaciers, then increasing temperature usually means an earlier ice melting, which then leads to an earlier spring peak in the rivers fed by those glaciers. So here's some information, and here the focus is on projections using a hydrological model for all of Europe. I won't go into the details here, but what you can see on the left is our maps on projected changes for the 4 seasons and for the annual average. Once again, blue means increasing river flow, red means decreasing river flow. The pattern of the regions and the seasons is very similar for precipitation. However, if you then look at the percentage changes, you often see that the percentage effects on river flow are stronger than on precipitation. So just to, let's say, invent a number, a 20% decrease in precipitation can well lead to a 40% decrease in river flow in the same season, because of the other effects I mentioned that influence river flow. On the right, you see for a number of rivers projections on how the seasonality changes. So the green is the projections for the future. And well, for some rivers, the total water amount is changing. But even if there's no change in the overall amount projected, such as, for instance, in the Danube River, you still see that the peak discharge is much earlier due to an earlier ice melt in the Alps in this case, or mostly in the Alps. Now we also look further on low river flow, or river flow drought, as you could call it. Once again, the pattern is similar. However, the effect of climate change, the projected effect on low river flows is often stronger than on mean river flow. And there are actually a number of regions or rivers where low river flow is projected to decrease, even though mean river flow is not projected to decrease. I should also say that low river flow is more difficult to model than the mean river flow, basically because some of the processes leading to these long-term droughts are difficult to model, and there's less data available to validate the models. So the uncertainties here are larger than for the mean river flow. And once again, this is also described in more detail in the publications. Now, changes in water availability affect not only rivers and groundwater, but also groundwater, and here in particular soil moisture is another relevant indicator and this indicator has been updated and changed completely since the last report. So if you're interested further, I encourage you to use the link on this slide to the indicator rather than the report. Once again, we see that since the 1950s, soil moisture has significantly increased in parts of Northern Europe and decreased in parts of Southern Europe. For this indicator, I have to say that even though this map shows past trends, these are modeled past trends. There are no, let's say, comprehensive measurements of soil moisture across Europe that you could use to produce such a map. So there is also model involved, driven by soil properties, by climate, and so on, to derive those trends. And you also see that this map actually shows the absolute trends, absolute changes in soil moisture. So those regions where soil is already dry, let's say in particular in let's say southern part of the Iberian Peninsula, do not necessarily show up as a strong decrease in soil moisture. It might look different if you use the relative map here. We also have projections for soil moisture, here using a somewhat different indicator. This is the so-called Palmer Drought Severity Index, one of the most prominent drought indicators. And this indicator, basically it's unitless, shows once again the similar picture as before, with increasing drought risks in Southern Europe, in particular in summer. Now, we also look at agriculture, and one aspect here is of course irrigation. Now the interesting aspect about irrigation is, or one interesting aspect is that climate change impacts irrigation in two ways. It has an influence on water demand, because increasing temperature changes the plant physiology, and at the same time it also affects the water supply. Now this map actually focuses on the water demand, or what is called the irrigation water requirement. Basically it shows how the water that would be needed for optimal plant production has changed in recent decades. Once again, this is something where you have to have a model underlying. You cannot measure this directly in the plants. And the map focuses on the past, showing for most regions in Southern Europe, or for many regions, an increase, although a different picture here for Southeast Europe, or for the Balkan countries in particular. And if we then look at projections, which is not shown on this map, we see that irrigation demand is projected to decrease by 1/4 for most of the currently irrigated regions in Europe. And if you contrast the increased demand with water availability, you'll see that there is not a good match. So many of the regions with increasing water demand actually have a decreasing water supply. So there are definitely important issues here, in particular in Southern Europe, where in many cases agriculture is already the main water users, and there is no additional water really available for agriculture. Just to finish the messages here, I'm just copying, let's say, key messages from the 2012 report on two of the issues. First one on precipitation, summarizing again an observed increase in most of Northern Europe and a decrease in most of Southern Europe, with important seasonal variation. Let's say the increase strongest in winter, the decrease strongest in summer. And this signal, this pattern, this regional and seasonal pattern is largely projected to continue in the future. Looking then at freshwater quantity and quality, we can already see the effects of climate change on river flow. However, it's actually not so easy to detect the impact of climate change because rivers are usually managed systems, and there are many other aspects that determine river flow. Anything from soil sealing to changing agricultural practices or land use practices, and so on. And if we then look at high flow floods, which I did not mention here, of course also changes in the river itself are very important. The patterns are similar to the patterns observed in precipitation, but they're often stronger, and also temperature effects and effects of ice melting additionally influence river flow here. Of course, here I'm focusing on, in this presentation, on water quantity, but we also look at other issues such as water temperature, which also has an effect on biodiversity, on energy production, for cooling water demand, and so on. And I would like to end with a slide showing an example on some of the methodological work we're doing. So this is a slide from the report, let's say it's similarly from simplified by the water group. They are dealing with reporting from member countries, and here what is shown here is actually how important it is to look at to obtain high resolution data. This is a region in Greece, but it's not really important what region this is, but it shows that even for the subnational region, the pattern, if you go from the river basin scale at the top to the subcatchment scale at the bottom, the pattern can look very different, and of course this has important implications then for water management. So we're not just working with scientific data and projections, we're also trying to improve the data collection from countries so we can provide, let's say, better comparisons, better advice on those issues. I think I've used my time, so thanks a lot for listening, and I'm looking forward to any questions you might have.
So thank you very much, Dr. Füssel, for this nice presentation. I would start with a question myself. We know that global projections indicate that demand for fresh water, energy, and food will increase significantly over the next decades, and especially climate change, as you have said very clearly, will exacerbate the pressures, and also risks associated with variations in the availability and distribution of water resources, and consequently on food and energy supply. So I'm referring to the water, energy, food nexus. And so I would like to ask you if you have in mind any solutions or any best practice that you would like to raise the attention to, and maybe something related to water energy nexus, which is very important specifically for like water pumping stations for renewable energy, for hydroelectric energy, and even desalinization, which is probably not so important in Europe, but it can be probably in the next century in the southern part of our continent. Thank you.
Yeah, thanks for this very relevant and also difficult question. I mean, it's true that climate change is an important driver, but if you look at solutions, of course, you also need to consider other issues, such as changes and possibly growth in food demand, energy demand, and so on, land demand. So we highlight these issues as much as possible in our reports. We're also increasingly producing, let's say, cross-cutting assessments which look at those issues together. However, the EA as such does not have the possibility to work specifically on let's say, global solution strategies. I mean, there are other institutions out there, such as IASA in Austria, which has dedicated research projects on this issue. Also, as EA, we are linking closely with research projects, for instance, by sitting in their advisory groups to obtain the best information, but that actually requires large model ensembles, linked models to identify which strategies work best in a particular situation. So we see our task as highlighting these issues, highlighting that, of course, if we are developing climate change adaptation strategy, then side effects on energy production and so on need to be considered. So we would be rather critical on large-scale desalinization, in particular if it's fueled by fossil fuels, but we cannot give specific recommendations to countries here where we can highlight the issue and then make the link to those who are actually looking further into this. So you will also find links to the key research projects, for instance, on the Climate Adapt platform.
Okay,
that's it. Oh, yeah.
Thank you. Yes, we received many questions now, so we'll start with this one. Is there any specific indicator you see to assess the pattern of change in floods frequency? If any, what are the outcomes in Southern Europe?
Okay, yes, we do have a specific indicator also on floods, and this indicator is actually also being redeveloped at the moment. In the end, I decided not to include the flood indicator here because the focus was on water resources. We don't have, let's say, reliable information on trends in floods. Mostly, I mean, we see an increasing reporting on floods over the last decades, but it's the flood databases are not good enough to distinguish what is actually, let's say, an increased reporting coverage through to better media coverage and so on, and what is actually the climatic factor. So we cannot really say whether there's already a trend in observed floods in Europe. However, global warming is intensifying the hydrological cycle, so that would suggest that floods in general are increasing, also in Europe, and we present maps for the so-called, let's say, longer-term floods, river floods, over several days, where if I just look at it, the pattern for Southern Europe is a bit complex. For the Iberian Peninsula, no clear trend is visible for floods. For Italy and the Balkan countries, increase is projected here. So these are kind of the large-scale floods triggered by, let's say, several-day rain events. And then there is another category of floods, the so-called flash floods, which are very local floods triggered by very short-scale events. And actually the most costly one in this century or millennium so far has been in Copenhagen, where within half an hour or so there were 15 centimeters of rain in 2011, and large parts of the city were flooded, and there was damage of about €500 million in just one city. Those very small scale local events are not yet well covered, neither by observations nor by projections. And basically this is an event where 10 or 20 kilometers away you might not have felt anything. So the observation network is not good enough to have precise measurements of that. I know many people are also working on those flash floods using satellite observations, using climate models, and there are some first results suggesting that these kinds of events are also intensified by climate change, but we don't have a proper European picture yet.
Okay, thank you. I have a few questions from our researchers here in Venice. So at the beginning of your presentation, you mentioned assessment of risk management. Could you elaborate a bit more on methods currently used for assessing the effectiveness of risk management?
Yeah, I think I also added a large disclaimer that this is just at the very beginning. I mean, it's basically looking, it's comparing the drivers and the outcomes. So for instance, if you have an increase in the drivers of river floods, but you see that less people are affected, less people are dying, then this gives you some indication that risk management in general is working. And I mean, I have to say, luckily, we do have an indicator looking specifically at damages and fatalities from extreme weather events and from including floods that kill a large amount of people are very rare in Europe. Sometimes, unfortunately, people die as an effect of a flood, but usually we're talking about very few people here per year, which of course is an indirect indication that the investments in flood management have paid out. Yeah, I can only say the general approach would be to compare the drivers with the outcomes, economic outcomes, health outcomes, and if there's a different trend in the driver than in the outcomes, it suggests that something is happening, and in particular if the driver is increasing but the outcome is remaining stable or decreasing, that gives a clear suggestion that risk management has been working. And I should say we're also working with other institutions on, let's say, adaptation indicators. And here a very broad distinction is between process-based indicators and outcome-based indicators. Our focus currently is on process-based indicators, looking whether certain processes are in place or being put in place. I know that other member countries are also working on outcome-based indicators. So for instance, I think 2 weeks ago, the German government published a so-called monitoring report of the adaptation strategy. Currently it's only available in German, but it will also be translated to English. And this monitoring report, or monitoring Bericht in Germany, includes 120 indicators on climate change impacts and responses. So they identified statistical indicators available in Europe that indicate, let's say, policy responses relevant for adaptation. So maybe some of your colleagues know German, but if not, it could be interesting to look at this report when it has been translated, probably at the end of this year, for some inspiration on how response or adaptation indicators could be developed.
Okay, we have here, a very precise question, if it's possible to have information on the seasonality of the indicators you discussed.
Mm-hmm. Yes, does the present question become even more precise in terms of a specific indicator, or what specifically is the question?
It doesn't say, it says like the seasonality of the indicator, so probably,
Yeah.
yes.
Mm-hmm. Well, I mean, for brevity, I've mostly shown just changes in annual sums or annual averages. In some cases, I've highlighted, for instance, for precipitation and low and river flow droughts, that decreases in southern Europe are strongest in summer. And of course, that is quite relevant if you're thinking of, let's say, agriculture or even tourism as main water users, power production. Then just knowing the annual changes doesn't really help a lot. Whatever, farmers don't work with annual averages, they work, at least if we're talking about rain-fed agriculture, with the rain that is falling in a particular season when the plant has a particular demand. So that's why we also provide as much as possible seasonal observations and projections, because that's relevant for many sectors. But yeah, I guess I'll stop here because I don't want to repeat what I said already earlier on the specific changes for specific indicators.
Sure. Then we have a question linked to this season. What will be the main reason for reduced summer flows?
Well, the main reason is a decline in those regions affected by it is a decline in precipitation and an increase in evapotranspiration due to increasing temperature. And if we're looking specifically at summer flows, also an earlier ice melting or snow and ice melting in upstream regions. So these are the main driving factors.
Okay, thanks. So we have a question on the financial implications of climate change related to water changes. So what are the financial implications? And I don't know if it's something that you work on, but maybe you can give some hints.
Yeah, we report a little bit on that. It is not the focus of our work, but we're in close contact with those researchers who are working on those issues. So the most recent report focusing on economic impacts of climate change in Europe is the so-called PESETA-2 report from the Joint Research Center of the European Commission, which was published last year. They used economic models to assess climate change impacts on various sectors across Europe. So that is an interesting source. There are also other EU projects such as Climate Cost and Econ Adapt. Looking at those, we are providing a summary, but we don't focus on those. So if I look at our report from 2012, maybe some of the highlights here is that damages from extreme weather events per year were around 10 billion euro in the first decades of the 2000s, and they have been increasing even after correction for inflation. The main reason for increases for the increased economic damage is actually changes in population, economic wealth, and also human activities in hazard-prone areas. But we presume that climate change also has some effect, although it's still difficult to identify or measure that effect. But for some categories, in particular extreme temperatures, heat wave, we can now quantify also or attribute observed changes to climate change. If we look overall at natural disasters, about 2/3 of the reported damages, economic damages, are due to so-called hydrometeorological events. These are kind of short-term events related to possibly to water, such as floods and landslides. Then about 20% of the damages are due to climatological events, extreme temperatures, droughts and forest fires. And then the remaining part is due to geophysical events such as earthquakes or something like that. So climate change is, or let's say climate is important for natural disasters, and I don't have right now access to the latest information from the PESETA-2 report, because that was only published last year, but we will report that, or will include that in the 2016 climate change reports. But yeah, we're definitely speaking about, I mean, in the long term, about potentially hundreds of billions of euros per year if Europe does not adapt to climate change. I mean, this project and other projects looking at the economics usually compare several cases or several different scenarios. For instance, a scenario where with socioeconomic changes only, such as population changes, another scenario including climate change, and then distinguishing further between no adaptation, complete adaptation, partial adaptation. But yeah, I advise to look at the moment specifically at the PESETA-2 report from the Joint Research Center.
Okay, thank you. Yeah, that's a very detailed. It's really a lot of money that if we don't act now. Actually, as you know, in the last G7 meetings, climate change played a central role, and
yes.
They have agreed to stick to the 2 degrees Celsius. What do you think? I mean, do you think that less dependence on carbon fuels will be part of policy Europe-wide?
Well, it has to be part of policies Europe-wide and also globally. If we are to limit climate change to global temperature change to 2 degrees above the pre-industrial level, then we are talking more or less about a full decarbonization of the global energy system. And of course, there's some potential for carbon sequestrations and carbon capture and storage, but so far this is only in experimental phases. That there are some limited facilities, I believe in particular in Norway, some experimental facilities, but it's not yet applied in a very large scale. So decarbonization then is really the only way to limit global climate change.
So you suggest also the carbon capture storage technology, and what about fuels? Do you think that biofuels, bioenergy could help in this process of decarbonization in Europe?
Biofuels could help. I'm not personally working on this issue, but interestingly enough, a few years ago, the EA and in particular the scientific committee of the EA looked at this issue in more detail, and let's say basically the message from this work was to be very careful with biofuels, to look at the whole, let's say, chain and the side effects, because biofuels can have indirect carbon emissions if they involve land use change. Also, their production often uses fossil fuels directly. So let's say the message from the EA was to be very cautious with biofuels and to distinguish where do they come from, how were they produced, did they trigger any direct or indirect land use change that would lead to indirect emissions. And I think these warnings have been taken on board in the European Commission. So I would say biofuels can be a part of the solution, but one should not be naive.
Yes, of course, and also this, as we said before, it's it's very important not to to solve the problem of the food energy nexus and probably developing
Yeah.
as much biofuels as
Yeah.
today.
Yeah.
It's risky for the land use change. But so don't you think that maybe biofuels with carbon capture and storage could be the solution in the future, maybe in the long term, but as a zero emission system?
Well, I have to say that EA is not working specifically on this question. I mean, I have contacts to colleagues looking at this issue. So I'm not reporting on specific EA work here, but more on my personal assessment of the situation. I don't think that there is one simple or single solution. I mean, the combination of biofuels and carbon capture and storage is very attractive because it's basically the only way to achieve negative emissions. But I'm not informed. Well, I know that there are different assessments on, let's say, the amount of biofuels that could be produced sustainably in Europe. Of course, there is a competition for land and possibly for water with agriculture, with biodiversity, nature protection. So I know that there's a lot of scientific and political discussion on this issue. It's definitely not the only solution. So other renewable energies are clearly needed.
Okay, thank you for this hints. So I would it's 1 o'clock, so we are very punctual. I would suggest to close the webinar here. So thank you very much, Dr. Füssel, for your presentation and discussion, and thank you for all the participants to the questions. And I would like to resume our webinars after the summer break. So you will get more information online on the dates and the topics. So thank you.
Okay, thank you very much for the invitation.
Bye-bye. Thank you.
Bye-bye.